So what have we got here? Well, quite obviously a Raspberry Pi Pico and an OLED display here, and there's a little clue there, it says Pico41. So if I type some keys here, let's try a 1 and a 2 and a 3, and then we push that onto a stack, which is a clue, and then I do a 2 and a 0 and a 0 and a plus. There we go, we've added two numbers together. Now that was obviously an RPN because I pushed something onto a stack and then did a postfix plus. So this looks like, and if I type another key, there you go, you can see there's a programming display for an HP41C. Now there's quite a lot of HP41C simulators and emulators about, but this isn't one. This is actually, if I zoom out a bit, it's actually a Raspberry Pi Pico sitting on a real HP41C calculator bus. So what's happening here is I've got some wires running from the Pico through some level shifters into this HP41C here, and this Pico is sitting on the bus inside the HP41, and it is taking everything it sees that's going to the display and is copying that onto the OLED display, which you can't see there. Let me prop it up with a glue stick. There you go. So if I clear the display here, because it's still in the program mode, if I take it out of program mode, you can see that 323 has reappeared over on the OLED. If I clear that number back to 0, 78, it's appeared there. If I go into alpha mode and type ABC, ABC appears over there. Take it out of alpha mode, and so on. So this is actually a sort of external display to the HP41C that I've got here. So I've just soldered wires. There's wires going in there onto the PCB inside the HP41C. So a few years ago I bought a batch of broken bits for HP41Cs, and out of the it's difficult to tell how many I bought, but I managed to build about 2 working HP41Cs, and I also had a few broken boards. So I thought it would be interesting to see if I could do the normal sort of bus sniffing exercise with the HP41C that I've done in the past with other calculators and pocket computers. And after a bit of work, because it's quite a complicated protocol to say the least, yeah, I actually got it working. So as well as sitting on the bus, I can press keys obviously on the calculator and they appear here, but what I can also do is actually, because I've wired up some analog switches to the keyboard, I can actually type the keys over on my my laptop here. So that's the 1 key and the 2 key, and that's not being done on the, well, it is being done on the HP41C, but it's not being done with the physical keyboard here, it's being done with analog switches on this board. So I can actually input keys over here. I can press the enter key by typing enter, and that's now entered onto the stack. I can also, because I can press any of these keys apart from the on key, that's a special key, but anyway, if I clear that, that's the alpha register. I've got some special codes here, so if I type a string, I can actually put letters up on the display in one go, so I don't have to work out where the letters are and so on. I can actually just type it as a string and they come up one after the other. So that's all quite useful, which means you could, if you wanted to, you could take a text file which has got an HP41C program in it and just type it in on the keyboard. You can also verify it because you've got the Pico on the bus looking at the display. So you can actually go into, if I take it out of alpha mode now, remotely, it's back to the normal mode. If I put it in program mode, we're in program mode, I can then single step through. There's nothing in there at the moment. I can single step through and actually check that the program that was typed in with the keys is actually the one that I expect in the memory. And that could all be done automatically by the Pico. I haven't written that code, not yet anyway. But it's doable because you have all the key inputs that you need, and you also have the display output here. Now this HP41C does not have any modules in it. It's just got 3D printed blank covers because the case actually came without any covers at all for the ports. But if I take it out of program mode here, clear the display, if I do catalogue 2, you can see that it's actually got a games ROM inserted, and that isn't a physical ROM, that is the Pico sitting on the bus, and it's got all the data that's needed for the games ROM in its flash. And when it sees the appropriate bus cycles, it presents that data on the bus of the HP41C. And I mean, the HP41C doesn't know whether it's a real ROM that's plugged in or something else. In this case, it's something else. So using this, you can reprogram the Pico and present a completely different module simply by changing the code. So I can do that. I've got my programming Pico Prog attached here, so what I'll do is I'll go to the source code for the device here, and I've got some scripts. If I find the right tab, I will, here we go, I will, instead of embedding the games in there, I will embed the maths ROM. So if I rebuild that, done, and if I flash it back onto the little gadget there, so you'll see the display will disappear here, and the HP41C might go a bit bonkers, but it's usually alright. So that's restarted now. So if I haven't touched this HP41C, and it had the games cartridge there. If I turn it off and back on again and do a catalogue 2, you can see now it's got the maths module in there, or the maths ROM. So all I did there was just take the code that was running and swap out the image that was in the flash of the Pico from the games image to the maths image. So if you wanted to, you could do that from an SD card or whatever if you had a different gadget, or you could have multiple ROMs in here and switch them over the USB. So the OLED display does have some strange sort of artifacts going on, and you can see there that the display is sort of shooting over to the left and things, and that's actually the way that the display controller in the HP41C works. It actually uses shift registers and so on to get the data on the display, and the OLED is fast enough to actually display that, whereas I think the LCD has got quite a lot of lag and you don't see that. I thought initially that the display would be off while it was doing that, but it isn't. So you do see a little bit of artifact there as the display is scrolled and rotated and so on to get all these things in and out of the display controller, or the two display controllers. There's two chips hooked up as a large shift register. So I think you could probably, in the same way that you've got the ROM image in there, you could, as well as putting any ROM image you wanted. I haven't got bank switching working, but that shouldn't be too much of a problem. You could probably, say you had an HP41C PCB that had a broken processor, you could probably emulate the processor and drive the whole thing from a Pico. Similarly, if you had a broken ROM, one of the mainframe ROMs, you could just desolder it from the board and replace it with an image that is presented by the Pico. Similarly with RAM. You could probably also expand the RAM up to the CX RAM if you wanted to. And I don't really see why you couldn't sit on the bus, and as well as sort of detecting the cycles that are going to the display and putting it on an OLED display, you could present the ROM for an HPIL link and actually emulate that as well, emulate the hardware for that. I think that would be possible. I haven't done it yet. So you could probably interface this over USB quite easily using this. Obviously this is a bit big at the moment, but you could, I'm pretty sure, and I think there might be space somewhere in there, you could probably shrink this down to a much smaller PCB and fit it inside the case, maybe. At the moment I've got this running off USB, which is quite nice. You can just take a USB cable and wire it up to the battery terminals, and the thing will run off 5 volts. Squeals a bit because it's a bit of a low voltage, but you can do that, and that's what I'm doing here. So there's no batteries in here. So you could run it off USB, use it as a development machine for creating ROMs or whatever, and maybe fit that PCB inside the battery compartment and just run it off USB. Obviously it's not very portable, then you need a USB supply. It may be possible to fit it somewhere inside the case and still have batteries, but the Pico is not a low power device. The RP2040 IC there is not particularly low power, and you drain the batteries pretty quick, so USB is probably a very good option here. So yeah, that's a project that I started quite a while ago, and I went back to it to see whether it was working, because it didn't appear to be working initially, but it turns out that apart from a couple of errors that I made with the PCB, it actually works perfectly. So everything I've tried so far works. Obviously if you want to create your own ROMs, this is quite nice, because you can just go in there, edit the image that's in the Pico flash, and then you just rebuild it, which takes that long, and then reflash it, which takes that long. So now I've got another image on there. So I've got a script that embeds a .rom file into the C as a C array. So you could run that script once you've created a new ROM image, rebuild it, flash it, and your iterative cycle of sort of code crash or code burn crash is pretty fast, because you can just put an image on there in, well, that was way less than a minute. That was more like 10-15 seconds to actually get another image on there. And you don't have to plug in or unplug any sort of hardware other than this sort of symbiotic device that's got its tendrils into this 41C's bus. You could maybe plug some of these connections in through a port connector, but the keyboard connection wouldn't be there, so the ability to type programs in and get them back out again would be lost. So at the moment I've got USB serial, I've got a USB serial interface, which at the moment is just running on Minicom. Now, because the device is sitting on the bus, let me restart that. Because it's sitting on the bus, you can do interesting things. So you can actually use this as a bus tracer, a bus analyzer. So I've got one of the cores of the RP2040 sitting on the bus with interrupts turned off, running quite fast. This is overclocked as well. I don't think really it needs overclocking, but it just made it easier. So that Pico is looking at all the bus cycles that are going on the bus, and then it passes that information to the other core, which can do various displaying and so on. The ROM emulation, the different ROM modules that are plugged in, is done by the core that's sitting on the bus, because it needs to do it within one bus cycle. The Pico that is sitting on the bus, as well as just looking and putting display information on the OLED display, it can actually do bus traces as well. So you can capture a bus trace and see what's going on on the bus in real time. You can actually stream it out in real time because there's only about 6,000 bus transactions a second, which is easily handled by the Pico, and that's not a problem at all. And the USB can actually dump it out, but then it scrolls past. So I've put a buffer in there, and you can actually get a trace. You can sort of, because the HP41C doesn't do a lot when it's idle like this, you can actually set the trace up, press a key, and it'll give a burst of bus cycles, capture those, and then you can display them over the USB later on. So as well as being able to put your own ROMs on there, you can also debug them on the bus by getting bus traces and seeing what's going on, which is how I was debugging the display code. I would do something, see what came up, it was wrong, so I'd go in and have a look and see what instructions are actually being sent to the display controller using the bus tracing feature that I've got. But yeah, it's quite an interesting little gadget, and for doing your own ROMs and so on, it'd be quite useful, I would have thought. So yeah, also I'm hoping to get some of the broken boards that I've got working by pulling the chips out and emulating them. So that's one of the reasons that I built this. The other was that it's just fun. One nice thing about the HP41C, which enables this sort of gadget, or makes it easier at least to make, is that it's fully documented. You've got assembler listings of the code that's running in here, so I could use that to see how the display was being talked to and work out which instructions I needed to sniff in order to get the display up here. I'm not actually sniffing all of them, I'm just doing the ones that manage to get a display that's usable. I don't think all of the instructions are actually used by the mainframe code. There's quite a few, and they only seem to use about 8 or 10 of them, I think. Or at least that's enough to get, you can get the program display up, it's all correctly justified and so on, and alpha works and so on. What is quite nice is that I can actually come over here and using my special key sequence, I can sort of type the names of programs and things without having to worry about where all the alpha keys are, because I can just type a string on my laptop, which is quite nice. I got a bit fed up with the trying to hunt for the letters on the calculator. But yeah, there we go. That's an oldish project that's moved along quite a lot.